Welcome back, my dear students, to my channel Civil Knowledge. So in this session we will continue our syllabus. Now in the last session we have seen some of the problems on parallelogram law of forces, and also we saw about the polygon law of forces. So in this session we will see the resolution and composition of forces, how this resolution and composition of forces are done, and when it is done, when it is coplanar concurrent forces. See, if two or more forces are acting in a single plane and passing through a single point, such a force system is known as what? Coplanar concurrent force system, right? Single plane, coplanar, passing through a single point, concurrent, right? So such types of system is given. Okay, the forces are given in such type of system. How we should find the resultant of the coplanar concurrent force system? It is our motto today. Okay, so we need to find the resultant of coplanar concurrent force system. See, let us consider these forces. See, F1, F2, F3 and F4 are on the same plane and they all meet at a point, that is at the origin here, right? So let F1, F2, F3, F4 represent the coplanar concurrent force system. It is required to determine the resultant of this force system. So how we should determine the resultant of this force system? So before determining the resultant, we have to do what? We have to do the resolution of forces. So in the method to resolve or split a single force, see, F1 is there, no? The method to resolve or split the single force into two perpendicular direction is called as what? Resolution of forces. What I am telling? See, F1 is this force and it is inclined, right? Now I need to resolve this, or we need to split this. How to split? So we have to take one in horizontal and one in vertical, and these forces which I am taking horizontal and vertical, it should be perpendicular to each other. Okay, these two perpendiculars will make this F1 force to be resolved. So this we will call as F1. So it will make an angle, right? So I'll take as alpha. This is F1 cos alpha. So this is F2 sin alpha. So like this we will resolve a force into two forces which are perpendicular to each other. So I'll tell you clearly. Wait. Okay, now see, it can be done. How it can be done? The resolution, it can be done by first resolving or splitting each force. We should split each force into its component forces in each direction. So F1 is there, we have to resolve this in each direction, that is F1. So if this is an angle alpha, so F1 cos alpha, F1 sin alpha. If this is F2, we need to resolve one in vertical and one in horizontal. If the angle is here, then it is what? F2 cos alpha and it is F1 sin alpha or alpha 2, whatever you take. Okay, then F3 is there, no? We should resolve it in one in vertical and one in horizontal. If this is the angle, what is that? Alpha 3, then it will be F3 cos alpha and this one be F3 sin alpha. Okay, alpha 3. So here see F4, one F4, what we have to do? We have to resolve it in one in vertical, one in horizontal direction, and the angle is here theta 4 we take. So it is what? F4 cos alpha theta 4, F4 sin theta 4. It's not cos alpha, it is cos theta 4 sin theta 4. Okay, you will learn this slowly. Okay, don't be in a hurry. So like this we will resolve each and every force. Okay, we will resolve each and every force, splitting each force into its component in each direction. So that is the meaning of this sentence. And then they are algebraically added. Then they are algebraically added means all the horizontal force are taken together. Okay, all the horizontal forces are taken in together and they are added, and all the vertical forces are taken in together and they are added separately. Okay, if all we see here, F1, F2, F3, F4, four forces are there. So from one force we are getting two components, that is one horizontal component, one is vertical component. Here F2, one horizontal component, that is vertical component. F3 horizontal, vertical. F4 horizontal, vertical, right? So in horizontal component, then we will add all the horizontal component. One, this I'll take as this one, 1, 2, 3, 4. We will add all this horizontal component, and then we will add this. By this 4 we will get one resultant of that all horizontal forces. Okay, that is the final force, F1, or I'll take as R1, RH as horizontal, right? Then similarly we will take in Y direction also. So this one, A, B, C, D, all the vertical forces will take as another force, that is resultant in vertical. Then we will get the two forces. From these 8 components we will reduce it to 2 components. When there are 2 components, we know how to solve it, that is by the parallelogram law of forces we will calculate it. Okay, just I showed you. See now, these two sums are then which sums? That resultant RH and resultant in horizontal direction and resultant in vertical direction. These two sums are then combined using parallelogram law to get the resultant of the force system. So this is the procedure to solve what? The coplanar concurrent force system. So I'll show you step by step now. See, so same force system I took. So let in the figure, let fx1, fx2, fx3, fx4 be the component of fx1, fx2, fx3 and fx4 be the forces in x direction. Okay, so this is x direction and this is y direction. Okay, so what is this small fx1? This is the small fx1. So f x1 horizontal. In the vertical, what we will take? F y1. Okay, of this f1. Next here, when we come here, so horizontal way. So how this is arrow is like this now. So we are taking this arrow that side only. Okay, so this is what? F y2 and this is f x2. Here also one horizontal component, one vertical component. This is what? F x3. This is f y3. So here f x4 and here f x5. So we are getting from 4 forces we are getting 8 components, right? So here they are taking only one, that is in x direction only. So fx1, fx2, fx3 and fx4. So this one be the forces in x direction. Yes, they are the forces in x direction, that is they are the horizontal, so which are in horizontal. Okay, let sigma fx be the algebraic sum of the component forces in x direction. Then sigma fx, the algebraic sum is equal to sigma fx equal to fx1 plus fx2 plus fx3 plus fx4. Okay, this is fx4. So fx1, fx2, fx3, fx4. Similarly, sigma fy is equal to fy1, fy2, fy3 and fy4. Fine. So once we get sigma fx and fy, so sigma fx is this one force, sigma fy is this. So we know that by parallelogram law, so that is r is equal to square root of sigma fx square plus sigma fy square. Okay, the direction of the resultant can be obtained if the angle alpha is made by the resultant with x direction is determined here. So alpha is equal to what? Tan inverse of sigma fy divided by sigma fx. See, here is the formula. Okay, the steps to solve the problems in the coplanar concurrent force systems are therefore as follows. So first what we need to do, So first we should calculate the algebraic sum of all the forces acting in x direction. We should calculate all the algebraic sum. How? We should first split, or we should first resolve it, okay, into its components. That is, if the force is in this direction, okay, we should take it one in horizontal direction and one in vertical direction. If the force is like this, we should take one in horizontal and one in vertical direction. Okay, so this calculate the algebraic sum. Then we have to add this algebraic sum in which direction, fx1 or this is fx2, like that. Algebraic sum of all the forces acting in x direction. Similarly, also in sigma fy, that is in y direction. Next, determine the direction of resultant using the formula. How to determine? That is this formula, alpha is equal to tan inverse of sigma fy by sigma fx. Okay, we have to find the first, we have to find the resultant. Direction is same formula, okay, tan inverse of that formula. Resultant, how we need to find? R is equal to sigma fx square by plus sigma fy square. Next, what? Determine the direction of the resultant using the formula. Alpha is equal to tan inverse of sigma fy by sigma fx. So these are the formula which we need to remember whenever we solve the resultant for coplanar concurrent force system. Okay, so sign convention C here. So this is x and this is y. Okay, so positive. So here x is also positive, y is also positive. So both are positive. Okay, sign conventions are very important when we solve the problems regarding the coplanar concurrent force system. Whenever we come here x will be, first I'll write about x. Okay, x will be negative, but y will be positive. When we come to the third quadrant, this is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. So whenever we come to third quadrant, here the value of x is also negative, y is also negative. Okay, whenever we come to here fourth quadrant, x is positive and y is negative. Okay, so in first quadrant both are positive, second quadrant negative positive, third quadrant both are negative, fourth quadrant positive and negative. So this you need to remember. Okay, this is very important. Okay, whenever we solve the problem related to the resolution and composition of forces in coplanar concurrent force system. So I'll explain you again. See here. So whenever we need to find here, so with the sign convention I will explain you. See, okay, here we have the image. See, with the sign convention, right? So sigma fx, right? Sigma fx equal to c. Sigma f1 is here. It is in the first quadrant, right? So f1 is there. How to? First I will make you to. So first I will what do? First I will do the resolution. So we will split the f1 force. How to split? So f1 is force is there. One we have to split in horizontal direction and one in vertical direction. And these force are called as what? Component of the force f1. So component force is what? Perpendicular to each other. Okay. So this is called as what? Sigma fx1 and it is called as what? Fy1. So similarly f2 alidalva. So f2 horizontal force and vertical force. Okay, it is called as what? Fx2 and it is Fy2. Similarly horizontal, vertical. Similarly horizontal, vertical. Okay, this is Fx3, this is Fx4, this is Fy3, this is Fy4. Okay, so we have to resolve the forces like this. After resolving this, we have to take all the x direction, fx1 plus fx2 plus fx3 plus fx4. We have to add them algebraically, that is summation of the forces in x direction. Similarly, summation of forces in y direction, that is sigma fy. So that is here done here. Okay, here see fx1, what I can take it as positive, value is positive. Then for fx2, x value is what? Negative. I have to take negative value of x. Okay, 1 minute. See, fx1 is what? Positive. I'll take positive value of fx1 plus fx2 value. Here it will come no. Here x value is what? Negative. I have to take a negative value. Okay, plus fx3, then again negative value. Okay, if it is negative, take negative. If it comes to be positive, take positive. But according to the rule in the third quadrant, if the x is in this direction, we have to take what? Negative. Okay, then at 4 x is positive. In the similar way in fy1 also, in fy1 if it is comes plus, it is plus. In fy2 it is also plus, positive. Fy3 it is negative, and in fy4 is also negative. So sign conventions are very important. So it will be, you will get to know when you solve the problems. So here you practice this, you resolve the forces, so that in the next class I will take the problems. Okay, so that we can solve the problems easily. Now we will see the resultant of non-concurrent force system. So whenever non-concurrent coplanar force system is given, how we need to solve? So the forces acting in a same plane and not meeting at a point are called as what? Coplanar non-concurrent force system. The forces may be either parallel to each other or they may not be parallel to each other. Okay. So non-concurrent force system is what? The forces on that plane, all the forces at that plane will not meet at a single point. See here, they are not parallel, but all the forces are not meeting at a single point. All the forces will have their own head and tail, right? Here also see, they are non-parallel, non-concurrent force system. Here parallel force system, non-parallel force system. So when this type of force system is given, how to find? Okay, so for the solution to the problems involving coplanar concurrent force system, the resultant can be found by resolving the forces into perpendicular direction, for example in horizontal direction and direction as vertical direction. That is same as we done in the coplanar force system. That is, if a force is given, we need to resolve it in horizontal direction and we need to resolve it in vertical direction. So this is horizontal, summation of all the horizontal directions and summation of all the vertical direction. So this is same as the coplanar concurrent force system. But for the solution of coplanar non-concurrent force system, in addition to that, okay, in addition to that, sigma h and sigma v, we need to determine another component called algebraic sum of the moments of forces as sigma m about a point. We should also calculate the moment about the point. Okay, and we should calculate the moment about the point, and we should calculate the algebraic sum of the moments of forces as sigma m about a point. We should calculate. So for coplanar non-concurrent forces, we should find what? The sum of the forces in all the horizontal direction, sum of the forces in vertical direction, and we also should find sum of the moment, algebraic sum of the moments of the forces about a point. So moment of a force. So what is this moment of a force? So the moment of a force is defined as the turning or rotational effect of a force about a point. The moment may be either clockwise or anti-clockwise. So clockwise is this, anti-clockwise is this. So O is a point, right? F1 is a force. So F1 is creating a moment about O. How to calculate? So moment about O is equal to F1 into X, that is F1 into force into perpendicular distance. So mathematically, how to calculate a moment? So moment is nothing but the force into perpendicular distance. What is the perpendicular distance? It is x1. So F1 into x1, that is clockwise direction. So it will produce the effect like this. Okay. If the force is like this, means it will produce the effect like this, that is anti-clockwise. Here only see. If the force is like this, it will produce anti-clockwise, but mathematically value is F1 into x1 only, but here we have to write anti-clockwise direction, force into perpendicular distance. This is how we will calculate the moment about a point O. Okay, about any point, if we ask to find a moment about this point, okay, so F here on force P is there, we need to find the perpendicular distance between these two. So this is x. So what is the moment about point? So moment about this point is P into x, like this. Okay, moment is what? It defined as the turning or rotational effect of a force about a point. So now we will see the geometric representation of a moment. Let F be the force acting at a perpendicular direction x from O. Let the force F be represented in magnitude and direction by the vector AB. Let O be the point of moment. See, we are representing now geometric representation of the moment. Okay, how we will represent a moment with the help of one geometry. Okay, so what they are telling, let a force F is there. Okay, it is represented in both magnitude and direction by the vector AB. Okay, so point O is here, so I'll take point O here. Okay, and I'll take a vector AB at a point here. So this is what A, B, and this is the force F1. Okay, it is at a distance of what? X. Now what I'll do is I'll draw a line so that I can form a triangle, that is OAB as a triangle, right? So I'll form a triangle OAB. Now what I'll do, I'll drop a perpendicular from O to on a line AB, that I'll take as D, or else I'll show you a diagram only. See, so force F1 is there, F force is there at a distance of X from O. Okay, join OA and OB, drop OC perpendicular to AB as shown in figure. So this is the setup. Now what I need to find, I need to find the moment of about O due to the force F. Okay, we know F into perpendicular distance is X, but we have to show in geometric way. So I'll take area of triangle AOB. So what is the area of triangle AOB? Half into AB into OC, half into breadth into depth, half into breadth into depth, that is half into AB into OC, right? Now multiplying both sides by 2. So whenever I multiply both sides by 2, what I'll get? So 2 into area of triangle AOB is equal to this 2 get cancels, that is 2 into area of triangle AOB is equal to AB into OC. Okay, so I'll take this equation as 1. So next what I'll do in the same figure, so mathematically what is the moment? So moment is equal to force into perpendicular distance. So what is force? F. What is the distance? Into X, right? So what is F? We magnitude and direction we represent it by AB, and what is X? It is nothing but the distance of OC. Okay, so this, as I'll take as it does this as equation number 2. So from 1 and 2, what we can write? The moment of force F is equal to, so the moment of force, this moment is equal to what? 2 into area of triangle AOB. See here, 2 into area of triangle AOB is what? AB into OC. Next, here also moment is equal to AB into OC. So from 1 and 2, what we can take out the result? moment of force F is equal to 2 into area of triangle AOB. So whenever we have a geometric figure, either you can calculate by moment is equal to force into perpendicular distance. When you don't have any perpendicular distance, you can also calculate by, so moment of force is equal to 2 into area of triangle AOB, where we can form the triangle. Then we can follow this method. That is, moment of force is equal to 2 into area of triangle AOB. So why I am doing this, we'll get this link in your next session. That is when we derive a formula for Varington's theorem. When we derive the Varington's theorem, now you will get to know why I did this. Okay. So this was about today's session. So I'll conclude now.